Okay, so now that we have a basic grasp of what stoichiometry is, which is just simply using those multiple ratios from the balanced equation, let's take a look at a more practical application of stoichiometry. And we'll use a slightly different equation to illustrate this process. So let's say we had nitrogen reacting with hydrogen to produce ammonia, which is NH3. So we want to make sure, again, whenever you do stoichiometry, you want to make sure that the equation is balanced. So we'll need a 2 in front of the NH3. We'll need a 3 in front of the H2. And then we don't need a coefficient. So 1 is understood in front of the N2. So that's our balanced equation. Let's say we're given the following information. So let's say if you started with let's say 55.00 grams of hydrogen, H2, how many grams of ammonia, NH3, can be made? Okay, so a couple things, just like in the previous examples that we're going to be using here. So we have a balanced equation and we're given some information. Now we're trying to relate. What is it that we're trying to find? We're trying to find the grams of ammonia, right? That's this thing here is what we're trying to find. And we're given the grams of hydrogen, which is this thing here. So we are relating the hydrogen to the ammonia, right? So that's what we're trying to relate in this problem. So relate the H2 to the NH3. We're not really concerned about the nitrogen. We're not giving any information about the N2. So we're just going to focus on the two things that we're asked, we're given information for, and then what we need to find. So the relationship between these two is the mole to mole ratio, right? That is the relationship that we get from the balanced equation. That mole to mole ratio is just the coefficient 3 to 2. So that tells me that 3 moles of H2 react to produce 2 moles of NH3. Okay, that is no different than what we saw previously. So again, the equation gives you that mole to mole ratio. It doesn't give you a grams to grams ratio. It gives you a mole to mole ratio. Well, in contrast to the previous questions, we aren't given moles, we are given grams of H2. So now, in order to use this relationship that we get from the balanced equation, which is a mole-to-mole ratio, we have to convert the 55.00 grams of H2 into a form that's usable, which is a number of moles, right? So we're given the grams of H2. We want to eventually convert that to grams of NH3. Well, we cannot do that in one step. Okay, there is no relationship that relates the grams of H2 to the grams of NH3. There is, however, a relationship that relates the moles of H2 to the moles of NH3, okay? And that relationship that connects one thing to another thing is the mole to mole ratio. So that is what we're going to be using here. We're going to use that mole to mole ratio from the balanced equation. So in order to use it, we have to get from the grams of H2 to the moles of H2. Well, guess what? Converting from grams to moles is something that we learned how to do. So we want to convert grams of H2 into moles of H2. To get from grams to moles, right, as we know now, we're going to use the molar mass of H2. Okay, and the molar mass for H2, we have 2 hydrogens. So every 1 mole of H2, look up a hydrogen on the periodic table, it's 1.008. So 2 of that will be 2.016 grams of H2. Okay, that will allow us to get from grams into moles. And then we can use our mole to mole ratio, just like we did in the previous question, to get to moles of NH3. Okay, and now we have one more step. You need to get from moles to grams. Well, guess what? We're going to use the molar mass of NH3 in this case, ammonia. Okay, so we just look it up on the periodic table. We have 1 nitrogen and 3 H's. All right, so that's nitrogen's 14 plus 3 for the hydrogen, so that's 17.0 whatever 2 grams of NH3. Okay, so that's your molar mass of NH3 that allows us to get from grams to moles. So we've taken this equation, this balanced equation, and we've used it now in a form that is in a way that's more practical. So we don't measure out moles in the laboratory, we measure out grams. So if we're given grams of H2, one of the reactants, we can calculate how many grams of NH3 we could make in this without even performing the reaction. We can calculate how much of the NH3 we should be getting just by doing stoichiometry. All right, so that's the path that we're going to take. Let's go ahead and set this up now using all of these conversion factors that we outline. So we always start with what's given. So we have the 55.00 grams of H2. Put that over 1. First step would be to convert the grams into moles. We're going to go from grams to moles. We're using the molar mass, which is this thing here. Okay, we're going to take that and insert it as a conversion factor. If I want to end up with moles of H2 in this first step, I'm going to put that on top. So every 1 mole of H2 is 2.016 grams of H2. Grams go away. Okay, so I'm at moles of H2. I want to get to moles of ammonia now. My mole to mole ratio that I'm going to use is 3 moles H2 to 2 moles of NH3. So I want to end up with moles of NH3, so I put the 2 moles of NH3 on top for the 3 moles of H2 on the bottom. Moles of H2 go away. And on the last step, going from moles of NH3 into grams of NH3, using the molar mass, allows us to get from grams to moles, moles to grams. And if I want to end up with grams, I'm going to put the grams on top. So that's 17.02 grams of NH3 for every 1 mole of NH3. Now, one thing to note here is your molar mass, by definition, is the mass of 1 mole of something, right? So even though when you balance the equation, you put the 2 in front here, when you calculate your molar mass, this is by definition for 1 mole of that thing, okay? We do account for the coefficients, obviously, when we use our mole to mole ratio, so you don't need to double incorporate it when you do your molar masses. So that's a common source of error for students do this. All right, so the moles of NH3 go away. And then the only unit we're left with now is the grams of NH3, which is what we wanted. So in terms of units make sense. That tells us our setup is fantastic. It's great because we only have the 1 unit left. So then calculated to use 55 divided by 2.016 and then times 2. We're going to divide that by 3. And then we're going to times that by 17.02, and that's going to give us this 309 for how many sig figs we have? 4 sig figs, so 309.5 grams of ammonia. Okay, and this is really the essence of stoichiometry, right? So we can use the balanced equation, which gives us a mole to mole ratio, to relate one thing in the equation to any other thing in that equation. In order to do stoichiometry, I'm going to write this down. Okay, in order to do stoichiometry, you have to get to moles. Okay, so you must get to moles in order to do stoichiometry, because the equation, the balanced equation, gives you a mole to mole ratio. So only then could you use the balanced equation, right? So you have to get to moles. So in our example here, we went from grams of something into moles of that thing, and we used the molar mass. of that particular thing. Okay, so all of your stoichiometry problems are going to boil down to this, getting to moles and using the mole to mole ratio. And then if we need to convert the moles back into grams by using the molar mass of the whatever the second thing is given in the problem. Okay, so when you do these, you need to slow down, think about what it is that you're doing. Okay, set it up, and the way that I set it up here, I've done it in a stepwise process so you can see how the units go away, how the units that you want remain, and everything else cancels out. So um, general steps that you want to follow, and then as you get more comfortable with it, then you can combine steps if you need to. But at the beginning, you want to make sure that you outline each of them individually to understand the steps involved.